In this video, we'll be discussing on regression. We'll be solving a question on regression. For more of this, you need to subscribe to this channel. We are asked to fit the data to the model. This is a regression model where we have B0 and B1 as the estimates. We have Y as the dependent variable, X as independent variable, and this is the error sum. So we are asked to fit this data into this model. So you need to subscribe to this channel to get more of this. Solution. The first thing to do is to recall that the estimate of B1 is equal to n summation x I yi minus summation of xi summation yi all over n summation xi all squared minus summation of xi all squared. This is for B1. And our B0 estimate is equal to y bar minus B1 estimate x bar. So these are the two things we are looking for in this question. The next thing to do is to spread this out. How do we go about it? We write it out, x and y. These are the values, the data given. We have x data, x values as 0, 1, 2, and 3. We have y values as 1, 4, 2, and 2. We also calculate for xi squared, which is this. The square of 0 is 0, the square of 1 is 1, the square of 2 is 4, and the square of 3 is 9. Also, we go over to xi yi. That means this and this. So 0 multiplied by 1 is 0, 1 multiplied by 4 is 4, 2 multiplied by 2 is 4, 3 multiplied by 2 is 6. The next thing we'll write, we'll find the total of all we have gotten. The total of this is 6. The total of this is 9. The total of this is 14. And the total of xiyi is 14. It then means that summation of xi, which is this, is equal to 6. Summation of yi values is equal to 9. Summation of xi squared, summation of xi squared is equal to 14. Summation of xi yi is equal to 14. N, which is number of observation, n is 1, 2, 3, 4. 4 observation, n is 4. We also have x bar. X bar is equal to summation of xi all over n, which is equal to 6 all over 4, which is 3 all over 2, which is 1.5. And we have our y bar to be 9 all over 4, which is 2.25. We come over to this place to calculate for our B1. Our B1 estimates will be equal to n. We have n as 4. We have summation of xi yi. Summation of xi, yi is 14 minus summation of xi multiplied by summation of yi. Summation of xi multiplied by summation of yi, which is 6 multiplied by 9. Also have the next one, n multiplied by summation of xi squared. N multiplied by summation of xi squared. Summation of xi squared is 14. So 4 multiplied by 14 minus summation of xi all squared. Summation of xi, which is 6 all squared. 4 multiplied by 14 is 56. 6 multiplied by 9 is 54. Multiplied by 14 is 56. And 6 squared is 36. So we have this to be 56 minus 54 is 2 all over 56 minus 36 is 20. It then means that B1 estimate is 2 all over 20, which is 1 all over 10, which is 0.1. We also have that our B naught is equal to y bar minus B1 estimate all over x bar, which is the same thing as y bar. We have our y bar to be 2.25 minus our B1. We've gotten B1 to be 0.1, 0.1. And our x bar is 1.5, 1.5. So if we make this out by rearranging it, we have 0.1 multiplied by 1.5. We have 0.15. So finally, our B naught estimate is what we are looking for. Our B naught estimate, if we subtract 0.15 from 2.25, we'll get 2.1. So these are the values for our B1 and B naught estimates. This is how we can fit a linear regression model. We can as well put these values into this model by writing it in this form. Y is equal to B naught. We have B naught as 2.1 plus B1. We have our B1 as 0.1x plus EI. So we can put the model, the values we got, we can write it as this. So this is how we can obtain the estimate of B naught and B1 in a linear regression equation.